Hey guys, welcome. Yeah, so this is the first of at least 5 additional examples in trig substitution. And yeah, so here the integral we have to solve is this. So, these additional examples are just slight varieties of what I've covered as the main examples. But yeah, so yeah. Now, we see that because of this trig identity right here at the top, the substitution we want to make for x will have to involve tangent. And what we want is right here, we want inside of the square root here in the first term, we want it to read 28 times tangent squared. That way we'll have 28 times tangent squared here plus 28. And so after we factor out the 28, we can write 28 times tan squared plus 1, which will be 28 times sec squared. And since I don't have room on the left, I'll just write the 28 on the right. The multiplication commutes, so we're good. Right? Okay. So we need this to be 28 tangent squared. Well, to make that happen, x, notice, has to be 2 times tangent of any angle, and let's use theta. Why not? So here we're saying let x equal, and I guess I'll write in white. I was tempted to write in this color green. But yeah, let x equal 2 times tangent theta, and that way the denominator of our integral, right? First of all, let's find dx. First of all, dx will have to be 2 times secant squared theta d theta, right? And otherwise, our integral will start to look like this, which is it'll be 7 times dx is what I just wrote, 2 times secant squared theta d theta, and so 7 times 2 is going to make 14. So instead of a 7, then I'll write a 14, and then times sec squared theta d theta, got it? And then divided by, right? Divided by, and in the denominator we'll have square root, right? Square root of what? Square root of, well, take a little bit of time to write this. Well, 7, and then it'll be x squared. Well, x is right here, right? So x squared will be 4 tangent squared, right? So 7 times 4 times tangent squared theta, right? That's 7x squared, and then plus 28, right? But I'll backtrack and write 7 times 4 is 28, and that's why we needed that 2 in front of tangent, right? Because we knew we wanted it to work out this way. So I'll have 28, and then tangent squared, right? Tangent squared theta, and then plus 28, right? Okay, cool. And as I said earlier, now we're going to factor out a 28 inside the square root and write. So we still have a 14, and then, well, actually, why am I writing a new line? I could just backtrack here. Sorry, guys. There was like an ambulance passing by outside, and like I turned off my mic for a second because I didn't want the ambulance siren to like get in the way of this video. They're annoying. I know they're saving lives, but still. Okay, so 28 times tangent squared theta plus 1. I want to make my videos too. Distractions. 28 times tangent squared plus 1 is secant squared, so it's 28 times sec squared. Right? Okay. And I suppose I can take a new line now to write this. Now, I have the square root of 28 times the square root of secant squared. So in the denominator, I'm going to get the square root of 28 and then times secant. Right? Okay. And in the numerator, notice I have 14 there. So now, because I want to combine the constants in the numerator and the denominator, this is what I'm going to do about it. I'm going to write one giant square root, and I'm going to fit them both in it. The 14, I'll put inside the square root as 14 times 14, or 14 squared, right? So that's 14 times 14. And then I'll have that divided by, in the denominator, I've got 28, and so I'll write that as 14 times 2, right? And that is 28, not 14.2. Well, okay, yeah. And then in the numerator, I have a secant squared theta d theta, and in the denominator, I have just a secant theta, right? Okay, cool. And so now I have the joy of some cancellation. So first, right, and then I could do this and write a 7 inside the square root. Just in the numerator, the denominator is 1 clearly, and then I could do this and get rid of that. Just get rid of it solidly. Yeah, okay, so now we can write this, which is integral. I have square root of 7. Actually, I prefer to write that outside of the integral, but I like the integral symbol that I just drew, so let's do that. And then, so square root of 7 right here. And then we have square root of 7 times the integral of no secant squared, just secant theta d theta. Now, I have already made at least one other video. I don't remember if I made 2, but at least one other video showing you how to integrate secant. And so the integral of secant theta d theta, let's slide this. The integral of secant theta d theta, and I'll link the video where I show you how to do this integral below this video. Right, I'll link it below this video. That's what I just said. This is natural log of sec theta plus tan theta, and then plus c, right? Okay, cool. So we'll have here square root of 7 times the natural log of absolute value of sec theta plus tan theta, and then plus c, right? Okay, cool. Now, all we have left to do is to get back from theta to x, and that's all going to be relying on our original substitution for x, which is that we made x equal to 2 tan theta. So based on this substitution, right, clearly tan theta is going to be x over 2. I took a chunk of something right there, as you could see, but it'll live. Alright. So we divide by 2 here. And so tan theta, right, is equal to x over 2. And we know that tan theta squared plus 1 is equal to secant squared theta. So we'll have x squared over 4 plus 1 is equal to secant squared theta. And based on that, we see that x squared plus 4, over x squared plus 4 over 4 is going to equal secant squared theta, right? And so taking the square root of both sides, we see that secant theta, taking the square root of both sides of this equation, that is, we see that secant theta is going to be a little something. It's going to be the square root of, and in the numerator, I'll have x squared plus 4 plus x squared, right? And then in the denominator, that 4, sorry guys, I don't like that 4. And in the denominator, I'll have square root of 4, which is 2. So I'll have this. So I've got secant theta right here, and then I've got tan theta right there. So our final answer is square root of 7 times the natural log of secant theta is what I just written down, which is square root of 4 plus x squared, or x squared plus 4, my bad, over 2, and then plus tan theta, and they both have a denominator of 2, so you could, just write them with a common denominator, but I'm just going to write x over 2 for tan theta. I could do that, and then plus c, and so that's it for this first additional example. Hope you enjoyed it and learned a lot. Yeah? Alright, cool. Take care.